Hi, in today's video I'm going to be covering using ffmpeg to display video scopes over a video. If you've used a program like DaVinci Resolve or any other video editor, you may notice that you can actually display scopes that will display the RGB levels, the waveform, a vectorscope and a histogram. And what you can actually do is use ffmpeg to do the same thing without having to import the footage into a video editor. So I'll quit DaVinci Resolve now and come across to ffmpeg. If you go across to the ffmpeg wiki over here and come down to the filtering section, there's some examples about creating histograms, waveforms, RGB overlays on top of a video using ffmpeg. So we've got fancy filtering examples, which have got stuff like histogram, waveform, vectorscopes. We also have waveforms here showing low pass filters, different kind of filters down here, RGB, RGB combined and overlaid on top of the video. We also have vectorscopes, which can have different colors, display the vectorscope and the amount of color and information in the video. And we also have histogram, which will display a histogram and can be overlaid on top of the video as well. And there's bunches of code here that actually does this, but what I wanted to do was actually recreate the scopes that you'd find in DaVinci Resolve using ffmpeg. What I'm going to do is come across to the terminal and show you a little script I've written that basically combines all those examples into one script and allows you to display waveform, vectorscope, Rgb Parade, and other stuff easily on top of video. So the script is called scope. Scopes, rather. If I type -H, it's going to print out the options that we can use with this script. And basically, we have several options. We can display a histogram. We can display an RGB overlay, which is all of the colors overlaid on top of each other. We can display an RGB parade, which is the RGB channels separated into separate waveforms. We can also combine the overlay and the parade under a video, create a waveform and a vectorscope as well as a histogram. What I'm going to do is demo this with some videos I've got here. So we've got Big Buck Bunny, Elephant Stream, and a video from the Magpie channel that I just downloaded. What I'm going to do is run scopes -I for the histogram, Big Buck Bunny, and what you'll see here is overlaid on the right of the screen. We have the histogram showing the different channels and the brightness, the luminance of the video. Okay, and I can fast forward through the video using the arrow keys, like so. We can see that information there. And that's the histogram. What I'm going to do now is come through and show you the next option we have, which is the Rgb overlay. And first of all, I should mention that I know histogram begins with an H, and it might make more sense to specify -H for the histogram, but we're using -H for help, which is more which is standard in script. So that's why I'm using -I for histogram, just to mention that. So what we're going to do is move on to the Rgb overlay. So we're going to do scopes, O for overlay, and Big Buck Bunny. And what you'll see under the video is the RGB channels overlaid on top of each other with in a sort of waveform here, with these green lines indicating the values of the particular channels. So as you can see, as I scroll through this, you can see there's a lot of blue in here. You can see the green, blue from the sky. Okay, so that's the overlaid RGB channel. So what we'll do next is look at the parade, which is the RGB channel separated into different waveforms, scopes, and P for parade, scopes, P for parade, big black bunny, and what you'll now see is the RGB channels separated into separate waveforms stacked on top of each other underneath the video. And I'll just pause that for a second. And as you'll notice, the more sort of vertical space we're taking up with the scopes, the smaller the video becomes, because it's obviously has to keep the aspect ratio. So that's why you get these black bars, and it wouldn't make sense to try and adjust this so that the waveforms go all the way across the page, because you would then having to be looking at the picture and then down this side, whereas everything's neatly underneath here, so you can actually see all of this at one glance, just looking up and down. So if I continue playing that, you'll see the channels here. And what I'll do now is show you the next option, which is the RGB Overlay and Parade combined and stacked. So that's -S, so scopes, -S, big black bunny. And what you'll see here is at the top we've got the 3 channels overlaid each other and then separated underneath the video, so that you can see both the combined result and the individual channels on their own. So if I scroll through this, you can see what I mean. And the other thing I wanted to mention excuse me, is these effects use different filters and color spaces, and you can't mix and match some together. So for instance, you can't mix the Vectorscope with the RGB Parade, because they use different color spaces. So what I'm going to do now is, I'll go into that more later. But what I'll do now is show the waveform with the -W option. So this is going to show the luminance of the video. You can see here it's really bright, it's really white, so the channel is right up here. I won't scroll through. See, that's the text coming up, fading out. Okay, so I'm sure you get the idea with that one. So let's move on to the next option, which is the Vectorscope. And what I'm going to do is I'm going to go through all of this in detail and show you all of the options for these different Vectorscope, these overlays that you can add to a video, so that you can actually tweak the script and change it if you want to a different display for that particular waveform. So what I'm going to do now is show you the Vectorscope with the -V option. And the Vectorscope here is overlaid on top of the video. And what you can see here is these are basically colours. So we have yellow, red, magenta, blue, cyan and green. And what this is doing is this is displaying the peak and the instant. So you can see here there's an outline. And what this is doing is it's displaying the results as they happen here. So you can see there's a lot of yellow and green and blue. But it's also showing you the actual peak of the waveform, and it's saving that so that you can actually see what the exact color space of the clip is, rather than trying to keep looking at it. So you can basically you can see throughout the whole clip how much magenta and cyan and green it's got. And if I fast forward through the video, you'll see it actually sort of resets, and as it goes along it will grow and it will retain the peaks. So you can see there, got a lot of yellow here, and that corresponds to the flowers here. Again, there we go, got the purple here. And what I'll do is I'll show you the different options for the vector scopes, but basically I found that this particular option is the easiest to read in my opinion, because the other options will show this in sort of black and white against perhaps a coloured background, but it's actually nicer to see this because you can actually see the colours in the vector scope, and makes it easier to then correspond the colours in the vector scope to what you're actually seeing on the screen. So what I'm going to do is come across, and I'll show you same thing with Elephant's Dream. So what I'll do is I'll go through this once again with another couple of video clips, and I'm going to go into some more depth about how this all works and how you can change the options in the script to customize the display to your liking. So we've got Elephant's Dream. So again, we'll do -H because I can't even remember some of these options sometimes myself as I'm doing this. So first of all, we'll do the histogram on Elephant's Dream. So scopes in Elephant's Dream, and you can see here we have the histogram. And Elephant's Dream is a open source film produced by the Blender Foundation. So if I scrub through this, you can see the histogram here.
So, you?
So what I'll do is then I'll move on to the next option, the Rgb overlay. So scopes, stream. That's going to show us the Rgb overlay under the video, so you can see how all these colors correspond to what's in the video and the actual strength of the signal here. So if I sort of fast forward through this.
Watch out! I'm okay.
Okay. So what we'll do now is we'll move on to the next option, which is the Rgb Parade. Scopes P for Parade, and Dream. And again, we're going to see the channels separated under the video.
We can see. Heard. What's next?
And next one again is the stacked, which is the overlay and the parade combined.
We can see the
Combined, and there's separate channels.
Heard. What's next?
So we'll have a look at the waveform next, and then the vector scope. Waveform, Elephant's Dream. See the waveform here.
I'm okay.
And finally the vector scope, and then I'll go through the actual script and some of these options. So you can see it's really nice having this because you can easily see what it's corresponding to on the video. Got a blue there.
What's next?
Big strike of red, so it's really nice being able to see this and then instantly identify, you know, what's on the video. So what I'm going to do now is actually come across and go through some of these options and the filter options in the ffmpeg documentation. So first of all, we have the waveforms up here. And you can see you can actually stack the waveforms either horizontally or vertically next to each other, like so, and underneath. So that's the waveforms. again, the waveforms up here, we have different options. So the low pass is what we're using for the luminance, the -W option. So we're just showing the, the brightness of the actual video. And the other one that I was using is the Rgb Parade, which is the channel separated. And then we have the overlay, which is where all the RGB channels are combined into one display. And you can also display the video on top of the waveform on top of the video. And what I'll do is come across to the vector scopes as well. So with the vector scopes, you have different options as to how the background and the actual color information is displayed against the background. So I'll show you in the actual script where you can change this, and in the documentation about all the parameters that you can change. So first of all, we have mode gray, and you can see again we have the little bit of text identifying what color it is, and then you have color here with a colorful background, so you can see red, magenta, green, and blue. These bits here are the actual options that you would pass to the bit of code when you're creating the vector scope. So we have color mode 2, color mode 3, and I think it's color mode 4 I'm actually using. Yeah, and then we have color mode 5, and this is the overlay here. So this is the actual overlay code, and as you can see, some of these have a particular format. So you can see that the Vectorscope Overlay, we're using a YUVA44P9 format, whereas if I come back across to the Rgb Overlay, we're using the GBRP format. And so that's what I was mentioning, is that some of these overlays and displays have different formats. So you can't, as I said, display the Rgb overlay with the vector scope on top of one video at the same time, because they have different formats. And what happens is it then changes the actual colors that are displayed in the vector scope and the Rgb monitor. So that's why there are different options to display one at a time. Apart from the parade and overlay, which I can combine, I can use the script to display them individually with their own option, or combined, because they both use the same format. So that's why I can display those two on top of a video at the same time, but not together with the vector scope or some of the other options. So the next one is the histogram. So you can see here's the histogram. I could actually display, if you want to display the histogram on its own, that would be possible with the Rgb monitors, because it's using the same format. But if you actually overlay it on top of the video, you can see it's using a different format down here. So rather than try and get all the scopes onto the screen at once, which might slow things down a bit, I thought it would be better just to do them individually, just do one job well. So what I'm going to do is come across to the ffmpeg documentation, and there's this is the filters documentation, which describes all the options that you can pass with these particular filters. So this is the waveform, which we were using, well, obviously for the waveform and the Rgb monitor, Rgb Parade and Overlay. So what you've got here is in display, for example, you have overlay, which is, for example, where we displayed the three RGB channels overlaid on top of each other. We can have stack, which stacks them vertically, or parade, which will stack them horizontally. The problem with the parade is that, especially with the waveform, is it takes up a lot of space to try and put them all together, so it's better to actually stack them underneath. Now the next thing I wanted to mention was, if I just go. Okay, so this is the envelope. So this is one of the options, for instance, that I mentioned with the Vectorscope. And the options you have are sort of instant, peak, and peak and instant. So instant is just going to sort of display the actual values as they're going along. Peak will show the outline, so it's going to retain the outline as I showed you in the video. It will retain the sort of outline as it grows. And then we have peak and instant, which is what I'm using to combine them both. So it will show you in real time the colors and how they're moving, but also show you the peak. And what we also have down here is the filters. So like low pass is what we're using for the waveform, and the reticule is the display of is used for the lines that are drawn to display the values in the scope. So you can see, you know, like 0, 25, 50, 75, 100. So you can display, you can change the color of the lines and the text. The other option you have is, by default, what it's going to do is it's going to show lines, which I prefer, but you can change it to show numbers and dots. And what that will do is it will display little green dots as opposed to lines across the screen. And we then have the scale, and the IRE is the one I'm using, but you can also use digital or millivolts. And the background opacity is how we set the background opacity for the overlay. In the case of the waveforms, we're not using, but in the Vectorscope, we're setting the opacity of the background when it's overlaid over the video. So there's a sort you can see through the Vectorscope to the video underneath it. And the other option is the histogram. Come up to the top. Find the blood thing. Ah, yeah. Where was it? Is this it? I'm scrolling too fast. I'll come up and do it manually. Video filters. Histogram. Okay, so this is the histogram options. You can set the level height, scale height, display mode as before, stack, parade, or overlay. And you have different sort of modes you can set. But what I'm going to do is just show you the Vectorscope, because that's got more options. And then I can show you how that corresponds to the Vectorscope up here. So you can see with the Vectorscope, what we've got is these different modes, as I said, grey, colour, colour 2, colour 3, colour 4, colour 5, and the overlay. So if we come across here, you can see these are the modes. We have, you know, said grey, tint, colour, colour 2, colour 3, colour 4, and I think I was using the colour 4 in the Vectorscope. So that actual colours present in the video are displayed on the graph, which is what we want. And we can set the the envelope, which is what I was talking about. So we can show the instant peak and peak and instant. So instant is again colors as they're happening displayed on the graph, and then the peak is the peak, which is the peak of the colors, and it holds the outline, so it draws an outline and holds it, so you can see the exact color space. And the graticule is what's used to display the color of the lines and some of the text. And all these options have shortcuts. So you can, in the script, you can either type mode, you can either say mode or M, or envelope or E, G. You can see here. And again, we have the opacity here. So what I'm going to do now is actually come across to the script and show you how this works. So if I come across to Emacs, what I'll do is show you how the script works and how you can install this, and go through how you can stack waveforms together. So first of all, what we start with is the shebang, which identifies the shell that this is going to run under. So this is a bourne script, and this is a shell script and not a bash script. And the reason for that is because it means it's more portable and it will work on Linux, Mac, Unix, whereas bash has a different path on each of those operating systems, and it has what are called bashisms, which are options and functions that are just specific to bash. So we're running a shell script, and first of all what we're going to do is we define the script usage, which is a function that is called either when the script is run incorrectly or without any arguments, or if we specify the -h option. And what this first little bit does here is when you run the script with an incorrect option, it's actually going to say that option is incorrect. So if you, for instance, ran scopes-a, which isn't a valid option, it would display -a invalid option, and then print out this help message showing you the various options that you can use in the script. So this section here corresponds to scopes-h. So when I run scopes-h, you can see it's printing this out, and that corresponds to this section here. Now the base name $0, what that means is when you run a script, the first argument of the script is actually its name. So 0 is when you're counting, with computers, 0 is the first, and then 1, 2, 3. So the first argument, number 1, is actually going to be the file you're passing to the script, but 0 is going to correspond to the script's name. So this is going to print out base name. So it's going to print out scopes-i in file equals histogram -o, Rgb overlay, etc., etc. So that's the first section that we want, is the script usage. Then we have some error messages. It's like not a file, requires an argument, wrong number of arguments, some stuff here. And then what we have down here is we're using getopts, which is a built-in function in the bourne shell that we use when we're typing -i, -o, -w. It will actually pick up those options so that we can specify different things to happen. The issue with getopts is it only runs when you pass an option with it. So it only kicks in if you type, -i or -o or -h. So what we want to do is also, if the script is run without any arguments, at all. So if you just run scopes, what we want to be able to do is actually say that we want it to print out the usage. We want to print out the script usage. So this section here means the number of arguments is greater than 0. So that means if you've done -i and then the file name, that's more than that's, you know, you've passed an argument to the script. If you don't pass an argument to the script, you just type scopes. See here, wrong number of arguments passed the script, and it displays the script help. So what this does is, if this section of code isn't greater than 0, it's going to run this bit of code here, which is the function, and then the wrong number of arguments here. So that's the variable here, wrong number of arguments. And what it's going to do is it's going to run the usage function up here, and -z. If you don't pass an error message to it, if there is an error message, it's going to run this section here, which is going to print out the error message. Okay, so that's the first thing. So what we then have is the functions for each of these overlays. So we have the Histogram Overlay, the Rgb Parade, Rgb Parade stacked, Waveform, and the Vectorscope. And finally at the bottom, what we have is getopts. So what I'm going to do is show you getopts and then switch back to the functions. And the order of the code is important because we have to place the functions that we're going to call in getopts before the getopts code. So you can see all the functions are above this bit of code because we're going to be calling these functions with the getopts program, depending on what option is passed to the script. So up here you'll see we have this chunk of code here, while getopts :I O P S W V H, and these correspond to these options down here, as you can see, I O P S W V H. And what we do is, first of all, we start it off with a colon because that allows us to catch error messages using this getOps piece of code. So, for example, if you pass an option that is invalid, like that -a, it's going to pick it up and then run the usage script and say, hang on, you're using an incorrect option, -a is an incorrect option, here's the actual options you should use. So first of all, we start off with a colon, and then we specify each of the options below here, separated by a colon, and the last one, H, is the help, and it doesn't have a colon after it. Now, this is basically a case statement. And what this is going to do is when you type -I, -O, or whatever, what it's going to do is it's going to create a variable called infile, which is going to be equal to the options argument. Let me explain that. We have -I, and you're going to give it a file to display the histogram. So you can see what it's going to do is it's going to run the Histogram Overlay Function when you use the -I option. And what it's going to do is it's going to create this variable called infile, which, as I say, is equal to the options argument. And the options argument is the file name you're giving it. So if you run scopes -I bigbuckbunny.mp4, the variable infile is going to be equal to that file name. And then what we're going to do is we're then going to run the histogram overlay. If I come back up to the histogram overlay here, this is the function, so the histogram overlay function here, and we call that, and you can see here this infile. So So we have ffplay, double quotes, $, curly doodahs, and infile. And the infile is going to be the options argument, which is bigbuckbunny.mp4. And then we're going to run the video filter. And with the histogram overlay, what we do is we use the split function, and we split this into two. So we have A and B. B is the histogram. So A is the video and B is the histogram. So we have the format, and then we basically create a sort of another variable called HH. And then what we do is we have A, which is the video, HH, which is the histogram, and we overlay that. And this section of code here, this is what places the histogram to the bottom right of the screen. So this is how you split the video and the histogram into separate components and then overlay them on top of each other. So what I'm going to come down here is next we'll come across to the Rgb overlay. So again, when you're doing this, what you have to do is for each of these options, they have to have a corresponding entry here. So we have :I, which corresponds to this, and then :O, which corresponds to this next section here. So :O is going to be -O as the option, which is going to be Rgb overlay, which is all three channels overlaid into one display. So again, we can reuse the same variable name here because they're in separate functions and it's not going to matter, and it just makes it easier to have the same bit of code and reuse it. So again, infile is going to be equal to the options argument, which is going to be the video file name. So scopes-o Big Buck Bunny. Infile is going to equal Big Buck Bunny. We then run the Rgb overlay function. Now, when you're running a accessing a variable, you would do it in double quotes with the $, and it's good practice to use the curly braces because there are times when you will want to add a variable to a string of text. For instance, when I'm saving a video in some other script, what I do is I grab the video's name and append a date to it, and you need to be able to differentiate the variable from the rest of the text. So it's good practice to put it in sort of curly braces. So again, infile is going to be the file name, and then we run the Rgb overlay function. So when we're calling the function, it's not in double quotes with a $, but when we're accessing the variable, it is. So that's the difference between those two, if you're wondering why they look different. So we come across to the Rgb overlay. Okay, so this is the Rgb overlay bit of code here. So again, the infile, that's going to be the options argument. So -O Big Buck Bunny, infile is going to equal Big Buck Bunny. We then have the video filter, and again we have the format, and the format for this is GBRP. And what we're doing is we're splitting this into two. So we have A and B. A is the video and B is the waveform. You can see here we can specify the waveform. It's going to be green, the scale, the flags. Again, the flags is how the lines are displayed. So you can either have solid lines, which is numbers, or you can have numbers and dots, which will display the lines as sort of like little green dots. And then we have the display overlay, and what this does is this isn't overlaying the display on top of the video. This is overlaying the 3 separate RGB channels on top of each other. So once we've done that, we save that as a variable BB, and then we stack A and BB. We use a vstack, so that's a vertical stack. So let me just show you what that looks like again. So scopes -O and Big Buck Bunny. So you see that's displaying the 3 channels overlaid on top of each other in one waveform. So that's not overlaying on top of the video, that's overlaying the channels on top of each other in one waveform. So we now come back across to the next section is the Rgb Parade, which is the -P option. Let me just switch back across here. So scopes -P, Big Buck Bunny, and that's going to display the RGB channels separately, each in their own waveform. So again, first of all, when you're doing this, you have to specify the -P option here. We then create the -P option, and again, the advantage of reusing the bits of code, you know, the same variable name in file, is that it makes it very easy to set this up. Again, -P, the in file is going to be the options argument, which is Big Buck Bunny. Then we run the Rgb Parade function, and again, the functions have to be above the getopts. We can't call something that hasn't been declared already. So we'll go back up to the Rgb Parade up here. Okay, and you can see this is the format of the function of ffplay in file, which is going to correspond to the video's name, the video filter, excuse me, and the format, which is GBRP for the Rgb Parade. And again, we split this into 2 because we're going to have the video with the Rgb Parade underneath it. So that's split into 2, which are variables A and B. So A is the video and B is the waveform. And you can see this is basically the same as the previous bit of code, except you can see here this has got display overlay and this doesn't. So the display overlay causes the 3 channels to be displayed on top of each other, but without it they're displayed separately. So again, we then have we create the waveform and save it as a variable BB. We then specify A and BB and vertically stack them. So again, we switch back, that sinks in, vertically stacked, separated, vertically stacked underneath the video. So that's A and that's B, BB rather. So let's move on to the next one. So that's the Rgb Parade. So we're going to next have a look at the stacked, which is the overlay and the parade stacked underneath each other under the video. So that's the -S option. Again, in file is going to be equal to the video file name, and then we're going to run the Rgb stacked function. And another thing is, it's important to run these as functions because otherwise the bits of code would actually be executed as they're going through the script, as opposed to when we specifically call them. So this is the stacked overlay and parade combined under the video. So first of all, we have again the video file name, the format GBRP. I'm going to split this into 3. We've got A, B, C. So A is the video. Then we're going to have B and C, which are going to be the parade and the overlay. So you can see here. So the overlay. So B is the overlay, which is all 3 channels combined. And then under that, we're creating C with the separate channels. Okay, now this is where it gets tricky. What we need to do is stack the video on top of two waveforms, and the vertical stack filter only allows you to stack two. Okay, so what we're doing is we create the first waveform is the overlay, and we're calling that BB. You can see we're creating a new variable called BB, and C is the separated channels, which we're going to call create a new variable called CC. Okay. Then what we do, take BB and CC, which are the two waveforms. We vertically stack them and save them as a variable called D. We can then take A, which is the video, vertically stack D underneath it, which is two waveforms. So when you're working with more than two items, that's what you have to do. You've got to separate them out into separate variables, stack them, and then stack the video on top of the variable. Okay, so that's A is the video. We split it into three, A, B, and C. So that's A, the video, B is the overlay, and C is the parade. We take B, we create the overlay, 3 channels, we save that as BB. C is then the separated channels, which we saved as CC. We then take BB and CC, vertically stack them, and create a new variable called D. We then can take A, which is the video, and D, which is the two waveforms, and vertically stack them. So let's have a look at that. So scopes, stack, Big Buck Bunny, and you can see what I'm talking about here. We have A, and then this is going to be B, and this is C. So that is then combined into D, and we stack A and D together. Okay, so that's how you stack things when you've got more than the one item. So let's come down to the next one. That's stacked. Now let's have a look at the waveform. So that's the -W option, and we're calling the Waveform Low Pass function. Let's come across to the Waveform Low Pass. Again, we've got the file name and the video filter. We're splitting it into A and B. A is the video, B is the width and the waveform, and this is the scale. The green, which is going to display stuff in green, basically the lines and stuff, and E, which is instant. So that's just going to, you can display peak and instant with the waveforms as well if you want to, but I'm just using instant. So that's saved as BB. We then stack A and BB together, which then gives us scopes, and let's different screen. And which one was I looking at? W. Sorry, W. Bad. Scopes W, elephant stream, and you can see we have the luminance scope underneath the video. So this is stacking the video on top of the waveform down here. Okay, and you can see these are the lines, and you can display these as dots as well if you wish. And the waveform and the Vectorscope have different options for the colors that you can display the lines in. I think with the Vectorscope you can actually display orange with some stuff. But now let's move across to the next one, final one, which is the Vectorscope. So this is the -V option, and this is what displays the Vectorscope. So let me switch back and show you the Vectorscope again. So scopes -S, and I'll do Big Buck Bunny, -V rather, Big Buck Bunny. And you can see here, this is the Vectorscope. And again, this corresponds, I come across to the Vectorscopes and I show you Vectorscopes. Remind you this, we have the different modes that we can use: grey, colour, colour 2, colour 3, colour 4, colour 5. And again, where's the Vectorscopes? We're on the Vectorscopes. Oh, there we go, Vectorscope. Okay, and you can see these are the modes that correspond here, and I'll just switch back to this and play it through. You can see just by looking at this, this corresponds to yellow, cyan and green, bit of magenta corresponds to that. And it's again, it's showing instant response as well as the peak. So it's going to show an outline of the entire color space within the clip. So as I scroll through using the arrow keys, see here, makes it very easy to identify what's on the screen, how it corresponds to the scope, and we have, you know, red, blue, magenta, cyan, green, yellow. We can just scroll through this. So you can even see there. Let me just come back. You even see that fluttering as the butterfly is fluttering. See that pointing to magenta. So what we're going to do is have a look at the Vectorscope code now. So again, that's the -v option, and infile is going to be the file name, and we then run the Vectorscope's function. And again, the option in the case statement has to correspond to an entry here, otherwise it doesn't work. So let's come across to the Vectorscopes. Oops. Right. So the vector. Right. So ffplay, the in-file name, video filter, and the format is YUVA44P9, and that's what's used for the overlay. So what we're doing is we're splitting this into two, M and V. V is going to be the Vectorscope, and the V option corresponds to the background opacity. So if we come to the Vectorscopes and search for the -B options, set background opacity. Okay. So if I just come back across there, you'll see as I play this and scroll through, you can see under the Vectorscope, you can see the video. So it's not just a big black square, and that's a background opacity of 0.7. So that's that. Then we have the mode color is color 4. Okay, and that is this. This is what we're using, mode color 4. If you come across to the filters documentation and come across up to the modes here, the color 4 actual colors present in the video frame are displayed on the graph, which is exactly what we want because it's much easier to read. In my opinion, the actual colors in the scope as opposed to black and white being displayed here. I just found it nicer to look at the actual colors in the graph. So that's the actual mode that we're using. So let's come across the next section, which is E, which is the envelope, and we're using peak and instant. So let me switch back across here. The envelope, this is what I was talking about. We have instant envelope and peak. And the peak is what holds the maximum minimum values present and presented in the graph over time. This way you can still spot out of range values without constantly looking at the Vectorscopes. So again, what that means is what I'll do is I'll use this video here from the Magpie channel as an example. So this is the Magpie channel chatting about new loan deals coming into Newcastle. I just thought I'd use this clip because it's something with skin tones here. We can actually see in the Vectorscope the actual skin tones and the colours present in the video as I go through
what
it,
Newcastle are after. Kane and more pleased at, but we don't.
like so. So you can actually see the skin tones and the actual color in the vectorscope of the amount of color present in the video. So it's a good way to actually check the skin tones of a video. So I just thought I'd show you that as an example of someone's face in a video. Do V and Big Buck Bunny because well I'll do Elephant's Dream, but Elephant's Dream is quite dark. You'll be able to see, for instance, here you can see this corresponds to this, so it just makes it really nice and easy.
We can see at the
If I
right,
leave
we
this to
can
run
see
through, you'll
the
actually
hat
see that
snarlers and everything.
you can see here it's showing the peak, and now it's retreated as the video's gotten darker. So it means you can actually see the full color space of the video clip. So that's the scopes. That's the envelope, which is the peak and instant. Corresponds to this section here in the script, and then we have F, which is another option. The flags name. So this draws color points short name. So this basically shows, like G, R, Y, B, S, C, Y for the different colors. And again, we have sort of like the background opacity. You can set the color space. So if I come across to here, and then what we're doing is that is then saved as a variable called V, and M is going to be the video, and we take the video, which is M and V, and overlay them, and use this bit of code here, which positions the vectorscope in the bottom right of the video. So those are all the functions and the options pertaining to each different display, and this is how we will actually call the options. And this is a very easy way to do this because rather than sort of like doing -I and then an in file and then maybe sort of like -T and specifying something like waveform, a histogram or something, it's much easier just to specify a different option like IOPS to type, and also it means it would be more redundant code later on if you then had to check the options past the -T or something. So this is a easy way to do stuff because it means you can easily create different options here and then call different functions. That makes it really easy to knock up different functions and change the options as you want, and then easily call all of these different examples in ffmpeg. So you can see down here, these aren't actually some of the ones I'm using. The waveform, so makes it easy to call, for instance, the Rgb Parade or the overlay, rather than like coming across the wiki and copying this bit of code and that bit of code, and then perhaps going to the Vectorscope and copying this big chunk of code here. Same deal with a histogram. Well, I thought it would just be easier to put all these chunks of code into one script and then call them with different options, rather than having multiple scripts which you've got to have maintain, one for the histogram, one for the vectorscope. It doesn't make sense to do that. It's more efficient just to have one script which you can call these displays with by using a different option. So what I'm going to do now is actually go through how you can install this and set it up. So if we come across here to my GitHub page, this is a selection of ffmpeg scripts that I've written and done a video tutorial series on, and I've added the scopes script down here. So what I'll do is I'll actually briefly go through some of these other scripts because I sort of updated one of them, which is the Ebu Meter. So I've got a series of scripts here, do different things, and you can see this is the load up YouTube eventually. Stay please. Okay, so this is the ffmpeg scripts install, and you can see this is basically there's the link. So this is how you install them, and I've got videos for each of these scripts and how you can use it. So first of all, what you're going to do to actually be able to run the script is what you want to do is create a bin directory in your home folder. So in my home folder, I have a bin directory with lots of scripts in it. So this is where I keep all my own scripts that I've written, and this is files. So you can see here bin, which is actually a symbolic link to a Git repository containing all my scripts. So this is the bin directory of all my scripts. So what we would do is create the bin directory, and you need to edit your bash or zshrc file and add this chunk of code here. And what this does is it checks if the bin directory exists, and then it prepends it to your shell's path. You then source your bash rc or zshrc file to pick up the changes. And what I typically do is create a folder called Git in my home directory where I keep all my Git repositories, and then you change that folder and clone the scripts down. So, for instance, Git ffmpeg scripts. See, that's all the scripts there. And if I open the file manager, see that's all the scripts cloned down from the Git repository. You can then either create symbolic links from those scripts to your bin directory, or just copy them into your bin directory. And down here I've got a whole section on actually installing ffmpeg on Linux and Mac and FreeBSD. And some of the scripts I've written, I'll briefly go through, is adding audio silence to a clip, because there's sometimes you might want to swap out a the audio track with just silence, or add silence to a clip that doesn't have an audio track. How you can batch process it. So combine clips lets you combine an image or video with an audio clip. So you can actually take a just a still and for instance whack a music track on it and it will create a video, or add a new audio track to a video, and you can batch process this as well. Correct clips is actually using GIMP curves to allow you to correct video clips, so you can actually adjust the white balance and add a tint and everything to an image from a video, and save that sort of GIMP curve, and then use it with ffmpeg to adjust the video clip so it looks like the still that you created in the GIMP. So this will let you white balance and adjust the contrast and stuff actually by using the GIMP, and I've done a whole tutorial series on that. And we've got an Ebu Meter. So what the Ebu Meter is it will actually display the loudness of a clip. So if I come across here, so Ebu Meter, let's check the options, -I and -T. So -I is the file I'm going to use, and -T is the loudness value in LUFS. And LUFS are a measure of loudness, and I believe that videos for YouTube should have a loudness level slightly under, commonly between sort of 3 to sort of 10, under 14. So if I do -T14, what you'll see here is the actual waveform of the audio from the video, and it will show you the target LUF level and how far off it you are. So if I come across here, extract frame is a script that will extract a frame from a video and save it as a PNG. So I could just do, if I just want to extract the first frame, I can just do extract frame and then the video extract frame -I big buck bunny Rgb bunny.png big buck bunny. So the first frame is blank. So if I do -S and format, so I can do hours, minutes, seconds. So if I want to extract a frame from 30 seconds, oops. There we go. See, that's extracted 30 seconds into the video. So that's how you can basically extract a frame from video, and you can batch process it as well. Fade clip is for fading a video clip in and out. Fade normalize is to fade a video in and out and normalize the audio levels. Fade title fades the video in and out, normalizes the audio, and actually creates a lower third title from the video's file name. So if you've got Big Buck Bunny, file's name, you know, Big Buck Bunny, it will create a lower third video, lower third title called Big Buck Bunny. Image to video converts an image into a video file. So you can turn a image into a video file so that you can bring it into a video editor or concatenate it with ffmpeg. Loud norm normalizes audio. No, it shows the loudness of the audio in the terminal and then normalizes it. Overlay clip is how you can overlay clip on top of each other. For instance, you can kind of like insert a video clip on top of another one. Overlay pip is actually creating a picture-in-picture, and there's a video on that using Big Buck Bunny. So you can see here we've got a picture-in-picture. So this is the base video. I'll show you. Play video. Full screen. Show you. And this is picture-in-picture. Picture. The picture got pan scan, which is like for scanning over a video, you know, an image up left, you know, that sort of thing. Subtitle add will actually take a SRT subtitles file and add it to a video so that it's a actual subtitles track you can enable. It doesn't burn the subtitles on top of the video. Is actually a subtitle track you can toggle on and off. And again, you can batch process that. And then we've got the scopes, which is what I've been showing you, and script usage and the options here. We've got tile thumbnails, which actually creates thumbnails from a video and tiles it into an image, so that it sort of quite creates a contact strip. And trim clip, which will actually trim a video clip to a millisecond. Can actually, I also updated it so that you can actually give it a YouTube URL, and it will use YouTube DL in the background and get the video clip sort of URL, and it will allow you to actually sort of trim a video clip from YouTube and just save that section to the computer. So you could say, oh, I just want to trim 30 seconds out of this video clip, you know, from 30 seconds to a minute or something, and it will just basically trim the video to that section and sort of download it, and you can batch process that as well. We've got vid to GIF, which will actually create a high quality GIF from a video clip. Again, there's a video demoing that. And we've got waveform to create a waveform from a clip. So, for example, come across here, do waveform -I Big Buck Bunny. What did I do? Maybe it's a file format I haven't set up. It should be. I'll have to have a look at that one. I'll have to have a look at that one, but allow you to create a waveform from video. It will create an image showing the waveform of the audio, and crossfade clips, zoom pan to sort of create a Ken Burns effect, panning and zooming across video. So that's a load of ffmpeg scripts that are created, and there's the scope script you can see up here, and that corresponds to the script I've been showing you in Emacs. So basically you can just come across and if you want, you can just download this. You just come across, actually copy all the code, button, you hit raw, and you could just come across, copy all that, save it as a text file, make it executable, stick it in your bin directory, and then basically it will work. And as I said, this is the ffmpeg wiki, and under the filtering section there are these examples: fancy filtering, waveform, vectorscope, and histogram. And basically we also have the ffmpeg documentation for the histogram, the waveform, and the vectorscope. So again, just search for vectorscope, and these are all the options that you can use. Yeah, so some of these options I've noticed for the reticule don't actually work, like the invert threw up an error, so I just leave it at green. And again, that's what displays the lines in the vectorscope. So what I'll do is I'll give you a brief recap of the script again. So let me just rm png. So scopes -h is going to display all the options that you can use. So we've got -I for the histogram, -O for the Rgb overlay, which is all three channels overlaid on top of each other. And we have the -P option for the Rgb Parade, which is the channels separated into separate waveforms stacked on top of each other. And then we have the -S option, which is Rgb Overlay and Parade, and -W is the waveform, and -V is the vectorscope. So let's do scopes -I, and what I'll do this time, I'll use
Newcastle left.
I'll use Magpie channel as an example.
Big thank you to everyone that
something different.
Brucey,
So you can actually see
here.
This is the histogram.
Remember that, and then but for what Newcastle.
So you can see it's quite dark. So you can see that's down there. These peaks here. So let's move on to the next one. -H. You want the Rgb overlay. -O.
Big thank you to everyone. Brucey, both were here. Remember that, and then read it.
All three channels overlaid on top of each other. Very similar to what you'll see in DaVinci Resolve. So that was the idea, was to actually replicate some of the scopes that you get in DaVinci Resolve using ffmpeg so we can actually check out the videos, stats and information about the color and luminance and stuff without actually having to bring the video into DaVinci Resolve, because the issue on Linux is the free version of DaVinci Resolve on Linux doesn't support H.264, so you've actually got to convert the footage into dnxhd, and I'll actually show you a script I wrote for that and the options I found that work the best for the dnxhd profile. So this is the Rgb overlay. So you will actually see no accelerated color space found for the conversion from YUV to this. So this is basically because we had to convert the color space to display the RGB waveform. So you can ignore that, that's not an issue. So again, scopes -H, and we want to display the parade, so scopes -P.
Big thank you.
Okay, so this will display this separately. And if we want to have the stack, which is the overlay and the parade combined, run the -S option.
Newcastle.
So there. And as you can see, as I mentioned before, the more vertical space we obviously take up, the smaller the video is going to be scaled down to. And again, there were some, I can combine these two because they're using the same color space, but you can't combine the RGB and the vector scope of the waveform because they're using different color spaces and stuff, so it mucks up the color. So that's why I'm doing these each individually as options rather than trying to cram them all onto the same screen. The other issue would of course be if we tried to cram a load of scopes onto the screen at one time in the terminal, the video would get progressively smaller as we added more scopes. So this is the parade.
Left at late. Bonjour, everyone. Big thank you to everyone that got in.
Okay, so that's the scopes. Now we'll have a look at the waveform, which is going to show us the luminance of the video. Scopes-W.
Newcastle left at late.
Okay, and what I'll do is I'll just leave this to face it.
Bonjour, everyone.
See, there's a lot of white here. So that's why this is all up here.
He thought he got rid of his big thank you, Brucey. But we remember that, and then for what Newcastle,
that's the actual
for whatever
waveform.
reason, give him a chance.
Now let's have a look at the Vectorscope with the -V option, which is useful, as I said, for checking stuff like skin tones.
Big thank you.
You can see here, this is good because this will actually show us the Vectorscope, and this is very similar to the Vectorscope on DaVinci Resolve, which would have a sort of skin tone line, which is the optimal sort of color spot for skin tone. So this is kind of useful for sort of replicating that sort of thing without firing up DaVinci Resolve, so we can come through.
Remember that.
We can actually see the entire color range taken up in the video here. So you can see dark spot corresponds to this, and this his face. So that's again the scopes and all the options that we have, and how the script works through script usage. We had the error messages, then we had the arguments check to see if enough arguments had passed through the script. We then had all the functions defined. Okay, that's all the functions. And those have to be defined above getopts. And then we use getopts. And each of these entries here corresponds to an item in the case statement, which is the option that you're passing to the script, like -I, -O, -P. These all have to correspond, and we started off with a colon because that allows us to do the error checking down here. So, for example, if I do scopes -A, you now see it says invalid option A, and it will then display the help. So that's the getOps, and again, each of these corresponds to an option, and the in file is again equal to the options argument. The options argument is the file name, so -I, Big Buck Bunny in file is going to be equal to Big Buck Bunny. We then run the function. So again, like the histogram, for example. Okay, and we have infile, which is going to be the name of the video. For instance, in the histogram, we split this into two, A and B. B is the histogram. We save that as HH. It has to have a particular format because we're overlaying on top of the video. And we then have A, which is the video, HH overlaid and positioned in the bottom right. And then same deal for Rgb overlay file name. Color space format is GBRP. Put it into two, A and B. B is the waveform. Okay, and it's overlaid, which means that the three channels are overlaid on top of each other. We save that as BB. We then stack A, which is the video, and BB vertically. So that then gives us scopes, overlay, stream. That then gives us all three channels overlaid on top of each other underneath the video. And then for the parade is exactly the same bit of code, except that it's not overlaid. So that means that we get the three separate channels in their own waveforms. So scopes, parade, Big Buck Bunny. You can see we have the separate channels. Okay. Then next we have again Rgb overlay and parade stacked. So file name, format GBRP, and we're splitting it into three because we're having the video, we have the overlay, Rgb overlay, and then the parade. So B is the overlay, we save as BB. We have C, which is the parade, which is saved as CC. And this is how you stack multiple items with ffmpeg. We have BB and CC, and we vertically stack it to D. We take A, which is the video, and D, which is parade and the overlay stacked. We vertically stack them, and then that gives us scopes stacked, Big Buck Bunny. That then gives us the overlay and the parade stacked underneath the video. Okay, so that's the stacking. That's an important thing if you're wondering how you stack multiple items. Then we have the waveform. Again, that's split into two, A and B. B is the waveform, A is the video, and we stack them above each other. And finally, we have the Vectorscope, which has got this particular format needed to display it on top of the video. We split it into two, M and V. V is the Vectorscope, M is the video. Dash B is the opacity, so this is the background opacity of the Vectorscope being overlaid on top of the video. Mode color 4, again, this corresponds to the Vectorscopes down here. So if you want to change the mode, if you don't like how the Vectorscope is displayed, you can change the mode into one of these other versions. But in my opinion, color mode 4 is the easiest to read. It displays the actual colors in the scope. And again, you can come across to the Vectorscope. Yep, you can come across to the Vectorscope documentation, ffmpeg filters, Vectorscope, and you can read the documentation and play around these. And again, we have the envelope, which is the peak and instant. So again, scopes, the Big Buck Bunny, see, using left and right arrow keys. And as I'm doing this, you can see how this is displaying the peak of the waveform, but also the instant. So it'll allow you to see the full gamut of color being used in the clip. So that's the peak and instant. The F was the name, so that's displaying, you know, G, B, Y, you know, for the colors and the Vectorscope. And again, what we do is we this is saved out as V again. And basically we take M, which is the video, and V, which is the vectorscope, overlay them and position them onto the bottom right hand side of the screen. So that's all the options that you can use in these different vectorscopes, the wiki, all the examples, the ffmpeg documentation, and again how you can install the script and all the other scripts I've written, which are basically to allow you to do some stuff you'd normally have to use a video editor for. Again, let me just switch back across to DaVinci Resolve just to refresh you on what we were trying to accomplish and replicate from a video editor using ffmpeg. Okay, so let me come across here. And I need to open the, where's the flipping thing gone? Okay, so this is just a video I was doing of people being interviewed about a community garden. And so if I come across to some of these clips here, we can see we have the scopes here. So you can see we've got the parade. I'll open up the scopes here. So again, we've got the 8. I think it's Xmonad. It's got some weird bug. Like I'll try and move the scope. Bastard. You can see it's gone right down here. Oh, there we go. Don't know why it keeps doing this. I do it really slowly. Okay, there we go. So we've got the parade, the waveform, the vectorscope, and the histogram. Okay, so these were the things that we were sort of trying to replicate. I think you can actually specify here just to show one or two. But again, this is parade here. That corresponds to scopes-p Big Buck Bunny, and I'm displaying them underneath the video, stacked one on top of each other instead of side by side, because it allows you to view more information. So that's the parade. Okay, so that's the parade. The waveform, that's going to correspond to the RGB waveform. So that's the scopes, the Rgb overlay, scopes overlay, Big Buck Bunny. That's corresponding. This overlay here is corresponding to the waveform in DaVinci Resolve, which was the -O option. And then we had the histogram and the vectorscope. So scopes -I for the histogram, Big Buck Bunny, bang it like that. And then finally we have the vectorscope. You can see here what I'm talking about, the sort of skin tone color line here. Shows that don't save. So scopes -V, Big Buck Bunny. That's our vectorscope. We don't have a skin color line. As I showed you with a clip of an actual person. This is
Newcastle left it late.
This is the Magpie channel, and you can see here we have a pretty accurate representation of the skin color, and we have red, magenta, blue, cyan, green, and yellow.
But we're fine. Big thank you there.
You can see as I sort of fast forward through the video
that the
position's pretty consistent, so it allows us to see,
at least for the next.
Okay, this is pointing a lot to the red, so there's a lot of red face. So that's the vectorscopes. So basically, that was the idea, was to recreate some vectorscopes from DaVinci Resolve with ffmpeg, so that you can actually easily use these chunks of code, the parade, the overlay, Vectorscope down here without having to copy chunks of code each time. And as I said, it just made more sense to put them all into one script and then use different options to display them. And again, you can't, there are some that don't mix and match again because they're using different formats. So the Vectorscope, because it's overlaid on top of the video, for instance, uses a different format than the Rgb overlay. So that's why we're displaying the scopes one at a time instead of trying to replicate the 4-up display of DaVinci Resolve using ffmpeg. So that's basically how you can use ffmpeg to create scopes, display them on top of the video or underneath to get some information without having to import footage into DaVinci Resolve. And that brings me to one other thing I wanted to mention, and that was converting footage to dnxhd to import into DaVinci Resolve. DaVinci Resolve doesn't support AAC or H.264 video in the free version on Linux because of codec licensing issues. So what I've done is written a little script that will actually convert footage from H.264 into dnxhd. And basically, if I just come across, show this where the script is. But go dnxhd, so Ubuntu bin dnxhd, and basically this is the function here, and what you have to do is specify a particular profile to convert the footage, and these profiles have different bit rates. And what I found is the minimum bit rate you can get away with is 145 meg. You do any less than that when you're converting 1080p H.264 footage into dnxhd, is you're going to get a lot of pixelation and artifacts in the video. And basically what this will do is this will actually increase the video's file size by 10. So if you've got something that's 1 gig and you convert it into dnxhd, it comes out about 10 gig. But that's just an issue with DaVinci Resolve free version again. So basically this bit of code will actually convert the footage, and I think I should have files of a location. Find the mount the video. Okay. So these are some short clips that were actually H.264 clips, and I then converted them, and you can see the file sizes they came out at. So originally, we come back to this one. You can see the file sizes down here: 30, 400, 700. Okay, so these are some of the videos, and then after you actually convert them to dnxhd, you can see they're coming out at much bigger sizes. And there's nothing you can do about that unless you actually pay for the pro version of DaVinci Resolve. But once you've done that, if I just come back into here, loads up. Come across the edit section. So these are all clips that have been converted into dnxhd.
It's gone. Let me just take you around and show.
From H.264, and then what you do is in DaVinci Resolve, when you export the clips, what you want to do is this is going to set a the clip is going to have a specific profile, DNX profile, which is going to be a 1080p 145. So when you actually export the footage, we imported it as it's actually saying DNX45 because I originally did it at 45 megabyte, and it was too small, so I sort of did another version and reconnected the video. But if I'd just imported the video straight away, it's a DNX145 1080p. But basically, when we import the video, it's going to be at 145. So when we export the video to dnxhd, again, we set the version, the profile to 1080p 145 120 15 8-bit, and that will basically then convert the video. It'll export it back out as dnxhd, and then what I would do is don't save is I would use handbrake. And what I did was basically there's a setting on the web. Yeah, so what I did was I selected the Vimeo YouTube HQ 1080p 60, and I copied it and changed the frame rate to 30. So I created my own preset, which is this one here. So basically it's going to be 1920 1080 high quality video and audio, and that I would basically use this to convert the DNxHD export from DaVinci Resolve into an H.264 file back from DNxHD, and that will reduce the file size by 10. So if you have like a 1 gig DNxHD clip, you can get it back down to like 100 or so using handbrake. So that's just another thing I wanted to mention was actually converting H.264 footage into DNxHD and PCM audio so that you can actually get it in DaVinci Resolve. And again, this is the format. This is the bit rate we have to use and the color output, and that will basically allow us to import the footage into DaVinci Resolve, and then again, as I said, you would then export it back out at the same resolution, just because there's no point trying to export it as a higher one, because it's not going to do any good. It's just going to create a bigger file size without any improvement in the quality. So that's the process that I would use, and basically what I do is this script, you just run it dnxhd-i and give it an in file and optionally an out file name, and basically it will convert the footage into DNxHD. And what I'd recommend is, because it takes up a lot of space, is actually putting this on an external drive, storing the footage on an external hard drive when you import and export from DaVinci Resolve as DNxHD. And then basically I'd just use handbrake just to convert the footage back into an H.264 file. Of course, you could use ffmpeg, but just for sake of convenience, using handbrake's nice and easy to batch process all the footage. And that's just a couple of things I wanted to mention. So that's the DNxHD script. And again, if we come across to the ffmpeg scripts, this is all the ffmpeg scripts and the scopes script. And all this that I went through how all this corresponds to documentation, how you can change it, and all the examples up here from the ffmpeg wiki, not whippy. And so that was the goal of the script, was to basically recreate the DaVinci Resolve video scopes using ffmpeg, so that we can actually have a look at the scopes without having to import them into DaVinci Resolve every time, because that's a bit long-winded. So that's how you can use ffmpeg to create really nice video scopes to view information about a video from all these fancy examples down here, waveforms, Vectorscopes with all the different color options that you can change. And again, I'm using color 4 to the histogram overlaid, which I'm positioning on the right hand side. And that's the ffmpeg filters, and you can search there for information about the histogram, the vectorscope, and the waveform. And again, this is the script that does the job. So the idea, as I said, was just to make it easy to basically be able to create these functions here for all these different examples, and then use getopts to easily run those functions by specifying a different argument like -i, -o, just p, and run the histogram, the overlay, the Rgb Parade, the waveform with the vectorscopes easily without having to type out a bunch of code. So I hope that's helpful, and that's all for now.